Hello again, everyone. In this video, we're going to go through the examples from exercise 6b, and this is where we start to get into finding some exact values with our sine, cos, and tans. So let's get stuck into it. In example 2a, we're being asked to find the exact value of cos of 5 pi on 4. Now, cos of 5 pi on 4 could be written as cos of pi plus pi on 4. And while it seems a bit unusual to write it this way, what this does is help us identify what quadrant our value is actually in. Because if we think about our unit circle, pi plus an acute angle puts us down here in the third quadrant, because we know that pi is over there. So the fact that we know that this is the third quadrant tells us straight away that cos of an angle in the third quadrant is going to be negative. Okay, so we know that our answer is going to be negative. The base angle is pi on 4. So our job really is to work out cos of pi on 4, but we know that the final value we give is going to be negative. So remember that to work out cos of pi on 4, we can go to our triangle that's got the pi on 4 angles in it, and cos of pi on 4, when we think adjacent over hypotenuse, doesn't matter which angle we pick here, adjacent over hypotenuse, either way it's going to give us 1 over root 2, but as a negative value, or negative root 2 on 2 if we rationalize the denominator. All right, next one. Find the exact value of sine of 11 pi on 6 is a pretty similar one. Here, we'll notice that 11 pi on 6 is just a bit less than 2 pi, because 12 pi on 6 would be exactly 2 pi. So we can start again by rewriting our angle, 11 pi on 6, as this time 2 pi minus pi on 6. And once we know that, again, that helps us identify which quadrant we're in. 2 pi minus an acute angle puts us down here in the fourth quadrant, and in the fourth quadrant only cosine is positive but sine is negative, and so we know that our answer is going to be a negative value. The base angle that we're working with is pi on 6, so our exact value is going to be negative sine of pi on 6. And to work out sine of pi on 6, we go to the triangle that's got the angle pi on 6 in it, which is our 1, 2, root 3 triangle, pi on 6 being that angle there. So we know that sine's opposite over hypotenuse, so opposite is 1, hypotenuse is 2. This is going to be negative 1/2. Moving on to example C. This is a similar kind of question, but just written in a different way. It says, if sine theta equals 0.5 and cos of alpha equals 0.6, find the values of sine of pi minus theta and cos of 2 pi minus alpha. So, starting with the first one, if we know that sine theta, sine of some angle, all right, let's say that it's there, is equal to 0.5, well, sine of pi minus that angle would just put us over here. Excuse that drawing, that's meant to be symmetric. And we know that in the second quadrant, sine is still positive. And by symmetry, by the fact that, this distance here is theta, that distance there is theta, and if my drawing was accurate, those two lines would be symmetric. Well, sine of pi minus theta will just equal sine of theta, which is 0.5, because second quadrant and first quadrant both give positive sine values. For the second one here, again, similar idea. If we think of our unit circle, we knew something about cos of alpha. Cos of alpha was equal to 0.6. 2 pi minus that same angle is just going to put us down here in the fourth quadrant, but again, with symmetry, we know that the value of 0.6 is going to stay the same. So our job really is just to decide whether we're in a quadrant where cos is positive or negative, and if we're in the fourth quadrant, cos is positive, and so we can say that cos of 2 pi minus alpha is actually just equal to cos of alpha, which the question told us was 0.6. So again, the value stayed positive there. If we ended up in the second or third quadrant, we would have just given our answer as negative 0.6. And lucky last example for this section. This time we've got a negative angle, so it means we need to think almost about going backwards around the unit circle. We've also got an angle with a pretty big magnitude, I suppose. 23 pi on 6 is almost 4 pi. We're almost thinking of 2 laps of the unit circle here. So I'm going to try to draw the unit circle a bit bigger. If we imagine starting at 0, so let's use a different color. Starting at 0 here, but because it's a negative angle, we're going to go clockwise as opposed to anti-clockwise. If we went kind of all the way around once, that would take us, I guess, to negative 2 pi, right? Or negative 12 pi over 6. We basically have to keep going almost another full lap to get to the angle negative 23 pi on 6. Or another way of thinking of it, sine of negative 23 pi over 6. It's like going two laps backwards, but then just adding pi on 6. Right, and if you really want to make that clear, you could even write this as negative 24 pi over 6 plus pi over 6. Oh, sorry, that's gone off the screen there. There we go. And so ultimately what's happened is we've just done 2 laps of our unit circle, got back to where we started, and then we're just going pi on 6 that way. And so at the end of all that, all we're really working out is sine of pi on 6. We actually did that one in the previous example. Back up in 1b, we worked out sine of pi on 6 was a half. And that's our answer here.